Welcome all the students in my YouTube channel Physics by TC Chauhan sir. Once again, we are with 12th board classes and we are today going to discuss about the force between electric charges. The force between electric charges was given by John Charles Augustin de Coulomb. It is known as Coulomb's law of electrostatic. What does it mean by Coulomb's law of electrostatic? Coulomb's law say that whenever two charges are there, two charges Q1 and Q2, and these are kept at a particular distance small r, then there will act a force between them, and this force can be of attraction or this force can be of repulsion. This attraction or repulsion force does depend upon the product of charges. It does depend upon the square of distance between charges. He told that the force between two charges is directly proportional product of charges. He told that force inversely proportional is square of distance between charges. He told that force depend upon the medium present and it will always act along the line joining. Along the line joining means either outward or inward. It depend upon these things. When we combine these, F proportional Q1 Q2 upon R square, then F is equal to K Q1 Q2 upon R square. K is nothing but electrostatic constant. Its value is K is equal to 9 into 10 to the power 9 Newton meter square per Coulomb square. Remember, its unit as well as its value. Value of K is 1 upon 4 pi epsilon naught, where epsilon naught is given by 8.85 into 10 power minus 12 Coulomb square per Newton into meter square. This is about K, this is about epsilon naught. Now, remember, what about force? Force will be K Q1 Q2 upon R square, or it will be 1 upon 4 pi epsilon naught. In terms of K, 1 upon 4 pi epsilon naught, Q1 Q2 upon R square. This is about the force. This is all about the force acting. This is about the Coulomb's law. Now, what about the vector form of Coulomb's law? Vector form of Coulomb's law is given in terms of R cap, etc. In terms of R cap means whenever we apply F vector, then there will be 1 upon 4 pi epsilon naught Q1 Q2 upon R square R cap. R cap means R vector upon R. R cap means R vector upon R. What about R cap? That will be R vector upon R. Just put its value. This will be F vector is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square R vector upon R. Then it become F vector is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R cube R vector. This is vector form. Now what about F12 vector? Whenever there will be 1 2, 1 upon 4 pi epsilon naught Q1 Q2 upon R12 cube R12 vector. And it shows the force acting on charge Q1 due to charge Q2. This is F12, remember. And what about F21? That is force acting on to due to Q1. It is given by 1 upon 4 pi epsilon naught Q1 Q2 upon R21 cube R21 vector. Since R12 is in this direction, R21 is in this direction. These both are in opposite direction. So F12 vector will be equal to minus F21 vector. It means Coulomb force always follow the law of action and reaction, that is Newton's third law of action and reaction. This is about Coulomb's law. Now, what about the effect of dielectric medium? If medium is filled between them, what happens? See, whenever medium is filled between these two charges, then how the force will get affected? Let us discuss about that. Then in this case, when medium is there, these are two charges Q1 and Q2. This is distance between them. Here medium is filled. Medium is of permittivity epsilon or dielectric constant epsilon r. Then what about the force? Then the force will be F medium is equal to 1 upon 4 pi epsilon q1 q2 upon r square. In place of epsilon naught, there is epsilon. It is permittivity of medium. So its value, as I have told you, epsilon is equal to epsilon naught epsilon r. Then it will be F medium is equal to 1 upon 4 pi epsilon naught epsilon r q1 q2 upon r square. Just put it in this way. F medium, keep 1 upon epsilon r outside, this will become F. Hence we can say that F medium less than F. That is, due to medium, the force will always decrease, force will always reduce. Remember, it is very, very important. That means whenever we are going to fill the medium between two charges, then electric force will always decrease, will always going to be change in terms of epsilon r depending upon value of epsilon r. There are a few concepts regarding to Coulomb's law. Coulomb's law follows inverse square law. That means F proportional 1 upon r square. Coulomb's law is acting only for electric charges. Coulomb's law is of attraction as well as of repulsion nature. Remember, it is having attraction nature as well as repulsion. Then Coulomb's law is a conservative force. Coulomb force is a conservative force. Coulomb force is affected by dielectric medium. In the case of Newton's law, it is not affected by dielectric medium, but here it is affected by dielectric medium. Coulomb force is applicable throughout in any place where charges are present. Coulomb force is a particular force which is comparatively strong. We know that in the case of gravitation force, it was the weakest force, but in the case of Coulomb force, it is comparatively strong force. It is comparatively strong. It has a large range. Its range is quite large. Remember, it is having large range. These are few concepts regarding to Coulomb's law. We start application of Coulomb's law. Application means some numerical question based upon the Coulomb's law. If we take question number first, three charges are given to you. These are three charges, Q, Q, and Q. These all are identical charges. These are given. And it is an equilateral triangle. Equilateral triangle means having same angle, 60 degree each, and same side, L, L, and L. Now, what about the question? Question will be, what will be the net force acting on any of the charge? Suppose this is charge Q on which we want to find how much force it will act. If we concern about this charge will experience a force due to these two charges. This force is supposed to be F1. This force is supposed to be F1 again. Question arises why we have taken these two F1. Because distance and charges are same. Then this angle will again be 60 degree. Then what about the resultant force? First of all, the force acting F1 will be KQ square upon L square. It's very simple. The formula of Coulomb's law, KQ1 Q2 upon R square. Now, what about the resultant of these two F1? The resultant of these two F1 will be given F is equal to under root F1 square plus F2 square plus 2F1 F2 cos theta. Then the resultant will be F is equal to under root of F1 square plus F1 square, because F2 is equal to F1, both are same, plus 2F1 square cos theta. Then it will become 2F1 square plus 2F1 square into cos 60 is 1 by 2. So it will be 1 by 2, it will get cancelled. There will be 3F1 square, it will be root 3F1. And F1 is, the net answer F will be root 3 KQ square upon L square. This is very important question. Another question, question number second. If these are three charges, Q, Q, and Q, identical charges are there, and it is an equilateral triangle, side L each. As at centroid of this triangle, we are going to keep another charge Q. Then what about the net force acting on it? Let us discuss. The net force acting on this charge capital Q will be, due to this Q charge, this will be force F1. Due to this Q charge, this will be force F1. Due to this Q charge, this will be force F1. Again, the question arises, why each and every is F1? Because the distances are same and charges are same. These two forces will give the resultant F1 in this direction, and hence the net force due to this one and this one will get cancelled. So net force will be 0. So whenever a charge is situated at centroid of a equilateral triangle, then the net force will be 0. So it is again an important question. Let us discuss about the question number 3. It's very simple. If there is a nucleus, radius of nucleus is given to you, and two protons are situated exactly at diametrically opposite ends at maximum distance, and you have to find the net force acting on these two protons. What about the force? The force will be F is equal to K Q proton upon R square. This we should take it capital R because this is small r. Then what about capital R? Capital R will be 2 into small r, because capital R is diameter, that is distance between protons, maximum distance. Then K Q proton square upon, just put its value, it will be 2r whole square. Then K Q proton square upon 4r square. Let us put the values of these. You know, the value of K is 9 into 10 to the power 9. Charge of proton is 1.6 into 10 to the power minus 19 whole square. 4 into, what about the radius of nucleus? It is 1 Fermi, 10 to the power minus 15 meter. Just take its square and you will get the result. By simplification, there will be the net force acting on two protons situated at diametrically opposite ends. So I think this session will be very useful for you. You do subscribe our YouTube channel Physics by TC Chauhan sir. You like and share this video so that maximum benefit can be availed. Thank you.